Now, to introduce continuous compounding, we're going to first take a look at what we already know, which is compounding m times. Imagine that you have $14,000 to invest. This is your principal, so I'm going to say P is 14,000. Okay, so I define that. Then I'm going to have 11% interest. And so on the next line, I'm going to type R equals 11 divided by 100. Remember to always convert to a decimal. The next thing is it's 8 years. That's time. T equals 8. And this is continuous compounding, but I'm going to first say, okay, what if it was just once a year? So it's annual. The formula for compounding of interest, the amount that you will get at the end of the 8 years, is P, capital P, then 1 plus R divided by M. This is like what's called rate per period. And then you raise it to the power MT. Okay, so that's the amount. So if it's annual compounding, we got 32,263 and 53 cents. Let me actually round this also to 2 decimal places, because with money, you have dollars and cents. Okay, so that's what you get. Now, what if the amount of times you compound is now monthly? Okay, let's take a look at the difference. Now you see 33,617.56. Okay, so it is increasing. With monthly compounding, you definitely get more money. How about if it's something like daily compounding? So that's 365. Okay, so then I got 33,748 and 12 cents. It does seem like it's increasing, but maybe not as much as the previous increase. Now, what if it was instead of daily, every hour? Well, there are 24 hours in a day, so just going to multiply this by 24, and whatever this is going to be, 364 times 24. And that's going to be now 33,752.41. So it is a little bit more, but like about $4 more, something like that. Now, what if instead of hourly, you're doing it every minute? Okay, so that's multiplied by 60. What do we see now? So this is like minute. This is even more often. So this is again 33,752.59. So you can see now there is the only difference we can see is in cents. Well, what if it's not every minute? What if it's every second? So we're going to multiply this another times by 60. Now second, so it's that 33,752.60. You see that there's only 1 cent difference. So that's second. What if it's milliseconds? So we're going to multiply again by 60. You can see basically it's 59, 60. I mean, it's just because of rounding, it switches a little bit. But basically what the idea is that the more times you compound, the amount at some point is just going to stabilize and not going to change much. And this is where continuous compounding comes in. Now, the formula for continuous compounding for the amount in the account is P. Then you multiply this by E, which is what's called Euler's constant. It's kind of weird to pronounce it, but it's a famous scientist, Euler. It's like just a number, okay? It's a fancy number, but it's just a number. So it's E, which every calculator has, to the power RT. R is the rate, T is the time. Notice how there is no M, because M is compounding M times per year, continuous, you're compounding all the time. Think like every millisecond, okay? Now let me compute that over here. So I'm just going to say round also. P e to the power RT. And let's do 2 decimal places. So you can see that I get exactly the same thing if it was compounded every second, millisecond, or whatever. So this is called continuous compounding. And that's like the best thing you can do with your money. If somebody offers you continuous compounding, you always say yes. Well, that's the largest I can get. Okay, so it's 33,752.6.